On this edition of System 390 magazine, SIM, Computer Integrated Manufacturing, has America's #1 music equipment manufacturer rocking and rolling all the way to the bank.
Despite a rough ride in the oil business, Petro-Canada has found smooth sailing with CICS to manage a complicated nationwide truck fuel program.
The American steel industry is alive and well in Reading, Pennsylvania, as Big Iron is once again making steel a good deal.
IBM presents System 390 magazine with Roxanne Stein and Tom Ellis.
Hello, I'm Tom Ellis.
And I'm Roxanne Stein.
Welcome to the latest edition of System 390 magazine. It's a quarterly magazine for you, our IBM customers.
In this edition, you'll see and hear such things as how IBM is working with customers to improve gigs in the South, rigs to our north, and in between, revitalizing the American steel industry.
The sound of music in this country is often loud, and it's also big in revenues. Recorded music is our fourth most profitable export, with a current trade surplus of $4.5 billion. In Meridian, Mississippi, a music equipment giant is holding its own against fierce foreign competition, thanks in part to IBM's Computer Integrated Manufacturing Software, SIM.
PV Electronics is the nation's largest producer of musical equipment. We manufacture every link in the audio chain, from the time that you speak into a microphone until the sound comes out of the speaker on the other end.
Hartley Peavey completed his first power amplifier in 1959. Peavey's reputation for performance and reliability has spread to every field of music. Through the expansion and growing pains of the 80s, Peavey became the #1 American producer in the $880 million musical equipment business.
We had tremendous islands of automation, different groups of design or accounting or purchasing, separate entities having their own system of computerization.
When you have all of those islands, I think that you have a tremendous amount of exposure for data being entered incorrectly. And I just don't think it's the way to go.
We started out with an application transfer study where IBM brought in some folks, and it was a painful experience because we dissected the organization from the top to the bottom, looking at all of our problems, trying to coordinate that and eliminate the islands of automation that were hampering our ability to compete in the world.
Now, since 1988, we've made a pretty good bit of headway, and we're sort of in the business of dotting the I on SIM.
We use the computers here in our SIM environment to accomplish all the facets of the design. We actually enter the designs directly into the computer at the concept of the product. Once we do that, most of the processing is contained inside a mainframe computer or a hub, where all the data can be accessed by anyone who might be working on different pieces of the task of the product development. That would include electronic design, mechanical design, and also preparation for manufacturing.
We are forever trying to improve our time to market, and to be able to do that, we've got to be able to take first shot designs and go to market with. We haven't got time to rerun prototypes and do a lot of tweaking. This is the design file that we receive from the circuit board design group. It's the digital information for the circuit board that we have uploaded into CATIA via an IGES file. I'm going to take this file and I'm going to build up my mechanical design around that. When I've got a complete complete 3D model with the circuit board and all the mechanical parts put together. I'm going to take each of those mechanical parts, break them down into individual files that I can create blueprints off of. At that point, it's ready to either output the blueprint for the shop floor folks or send the soft file to the different NC type machines that will actually be used to produce the part.
We utilize CATIA as the base drawing product. We do use GDDM and GDQF as transport mechanisms, and have written REX code and to use those products to deliver an online application that a person can sign on to and search a drawing database. We attach graphic information to our notes and our documents in profs. We have occurrences of an engineer attaching a graphic file and asking a question of, here's the way I think this should look, what do you think? You can modify that graphic and return it to the person via our profs. That saves time, saves trees. The VM makes that happen for us, and that's really helped our communication, which is the bottom line of the whole SIM gig, is improved communication.
We can have a customer in Atlanta give us a call on the telephone and place an order. He can actually transmit down into our computer the order. It's received electronically. He's given a confirmation number, and then a series of events transpire all within the software. Immediately, an order is currently being printed out in the warehouse. Now let's say that we don't have inventory in the warehouse when that order was placed. It triggers master forecasting to increase the production schedules.
We've also established a link between CATIA and IBM CAD that we can download CATIA drawings or the 2D geometry information to our Armada punch press machine that punches our sheet metal, which we probably use for 80% of our products.
We no longer have multiple copies of programs lying around that we could accidentally pick up and make an early revision part. We always go back to the data source and generate that program again.
Only one person that has picked that order has ever touched it. That night, the mainframe prints out an invoice, and it's either faxed directly to them from the mainframe, or we can still mail it.
If we didn't have the CAD system, the state of our music product, so to speak, would be where we were about 3 years ago.
The mainframes network allows everybody to sing out of the same hymn book. You can't do that with PCs on a desk and a modem.
Bottom line, is SIM worth it to Peavey? Absolutely. We invested in our future. We invested in our ability to compete in the global market. We have to survive here in America, and we did it with IBM.
Another way Peavey is investing in its future with the help of IBM is in developing its own educated labor pool. Modern manufacturing needs trained labor, sometimes tough to find depending on your locality. If it doesn't exist, you have to build it. Learning SIM, CATIA, and practical hands-on job skills are not part of a regular college curriculum. Peavey, along with IBM and the Meridian Community College, have formed the Meridian Partnership to bridge the gap between the classroom and the workplace.
We are very fortunate in that we have a local community college that has people that run that place that have a vision, that understand what a business is all about and what it requires. As a result, we don't have a university here on the factory location, but we have a factory training on the university campus.
The partnership has educated more than 2,000 Peavey employees in basic education and factory skills. Last November, the Peavies received a National Literacy Award.
When we come back, we're going to take you to Canada, where IBM is working with that country's oil giant to make sure the price is right for truckers.
India, Bravo, Mike, and Alpha.
Advanced strategic intelligence means accurate information to analyze yours and your adversary's technology, strengths, and capacity. I'm General Tom Kelly. As Director of Operations for the Joint Chiefs of Staff, I relied on those accurate technology assessments. These days, there's a lot of technology changing hands. Figuring out how it might get used and how it will perform in an uncertain future is the role of advanced strategic intelligence. Now IBM offers advanced strategic intelligence on mainframes. Accurate information to analyze the performance and capacity of IBM machines and the competition. LSPR, IBM's large system performance reference, lets you, the customer, accurately measure your future mainframe capacity benchmarked against your individual workload projections. Batch, online transactions, engineering, and scientific. IBM has had LSPR, Advanced Strategic Intelligence, on mainframes for years, but until now it's been confidential. Now it's available to you.
From India, Bravo, Mike.
Call your IBM representative to get it. You can't afford not to.
Bravo, Mike, identifier, Lima, Sierra, Papa, Romeo. From India, Bravo, Mike.
Especially in these economic hard times, cutthroat competition is a sure rule of the road for the truckers who move our goods from one place to another. North of the border, the men and women who drive those rigs are benefiting from a program Petro-Canada just moved in-house that links mainframes to fuel pumps to cut costs.
This is Calgary, Canada's burly, bustling petroleum capital, home of the Winter Olympics and the world-famous Calgary Stampede, and home to the nation's oil companies. Every day they battle shrinking margins for those elusive market share decimal points that mean the difference between growth and decline. Petro-Canada, like all other oil companies, is suffering through downsizing pains. And it had a rough ride last year. And they're still getting bounced around by declining oil prices, stiff competition, and a deep, stubborn recession.
If you're just selling a commodity, diesel is a commodity. There's nothing glamorous about it.
Like all commodities, diesel fuel is extremely price sensitive. Discounting is rampant in the battle for high-volume truck fleet buyers.
The oil gas business is extremely competitive. Our thrust over the next few years is to concentrate on our expenses. Again, reducing our expenses will yield us a better return.
One expense Petro-Canada has cut is computing and billing complex volume discount contracts with major truckers in a program called PetroPass. Long-haul truckers use special credit cards that unlock pumps, record sales, then relock pumps 24 hours a day, even at unmanned stations.
That's it. Yeah, got my unit number, fuel, great.
The headline for truckers is round-the-clock fuel availability at their individually negotiated price. The headache for Petro-Canada is tracking and billing thousands of daily purchases with each a different discount.
This is Petro-Canada's Centre of Operations for all of Canada. This is basically where the terminals for the PetroPass system are fed into. From here they then go into the KICS terminal owning region on the MVX complex, and from there they get fed into the PetroPass system.
And we will process it and price it. And then we will pass that information off to the mainframe for subsequent billing. At the same time, we take that information and put it onto our online server. And our online server is then available to the agent at the site.
They were paying outside third-party vendor to supply this service for us. We decided to insource it.
So last year, Petro-Canada began developing systems to manage PetroPass in-house. They chose IBM's Customer Information Control System, CICS, or as it's called in Canada, KICS, with OS2 hooked to a couple of PCs, while their mainframe manages communications and billing.
After all, the PS2 Model 95 is a very powerful machine in the PC world, but it cannot handle 200, 300 terminals spread across Canada. It just can't handle it.
Who's
cruising front, Petro-Canada.
The horsepower of that mainframe comes in downright handy when you're trying to pull a wagon load of terminals just a few years removed from the horse and buggy era.
We were presented with a very, very tricky problem. We had a network clear across the country coming in via packet switching network of VT220 terminals, old ASCII DEC terminals that used 2400 baud dial-up modems. And they wanted to keep that. They didn't want to have to buy 150 or 200 PCs and somehow connect them up via high-speed leased lines. That would have been very expensive, and the whole idea here was to save money after all.
The development costs we found were considerably less than we'd anticipated, and the ongoing operating costs were for sure a lot less than we had anticipated. And I won't give you the dollars.
We're only spending about 10% of what we used to, and now we're providing our users with an incredibly flexible system. Not only that, we're providing it at a minuscule cost when compared to what they used to pay.
Clients sent their bills back saying basically that this was too cheap.
Every time you bring a new program out of the chute, you always have your share of ups and downs, and Kix is no exception. So IBM gave Petro-Canada a leg up.
They actually came in and lent us a hand and got us up and running with the LU 6.2 links from the PCs to the mainframe and vice versa, and we can't complain. We're very happy that they were there to help us at the time, because that was the toughest part.
We decided the optical disk was going to be the primary read-write storage mechanism for the PetroPass system. Had a lot of problems initially as we tried to interface that ourselves with the server running under OS/2. Really had to turn to IBM for the help that they could provide us in terms of making that all run seamlessly.
CICS OS/2 is working so well on PetroPass, its reputation is outrunning its capability.
It's not something that you can run an entire company on. In fact, probably part of the problem is convincing people that it's not a solution to absolutely every application need out there. It's just a product that has its place in the Kix family.
And that family is getting bigger and better. As this broadcast airs, IBM's UK labs in Hursley, England are getting ready to release a new version of CICS that Petro-Canada has already tested.
We have the new flagship product from Hursley, KixCSA version 3.3, installed and working. And that means the mainframe can tap the PCs on the shoulder now and get stuff from it very easily. Whereas beforehand it used to be targeted the other way around. But we're finding a lot of PCs scattered all throughout the country now. And effectively now the mainframe can ask them for data very easily. It could always do this before, but it would take a little bit of extra work and effort. Now basically we have the ability to go both ways very easily with KixCSA version 3.3.
No matter what business you're in today, there are no smooth rides. And CICS may be just the kick you need to keep you just a little ahead of the competition.
It's Petro-Canada!
IBM is announcing new product enhancements to Information Warehouse. First, a new DB2 release for MVS will offer improvements in system integrity, increased input-output parallelism, and extended support for databases on geographically separated computers. Second, DB2 is now a family of products with our announcement of DB2 6000 and implementation for the RS 6000. The warehouse is IBM's solution to the problem of accessing accurate information from all the data spread throughout a business, contained on equipment from IBM and other vendors.
In another announcement, IBM has introduced multi-protocol transport networking. This will allow different protocols like SNA and TCP/IP to be transmitted over a single link connection.
When we return, new life in a once dying industry where the foreman may look like nobody you've ever seen.
Racing is like business. To win, you need performance, reliability, and more storage capacity. Sound like your business? Every week we add new stuff to store, but no room to store it. Sound like your computer operation?
In the tradition of excellence of IBM storage systems, this is the new IBM 9340. Speed, reliability, and performance needed to keep you in the race.
9340s may be the difference between getting 70 and 80,000 cartons a day through a distribution center.
They're fast and they're compact. That's what I like about them.
We run the systems for 7 days a week, 24 hours a day.
We really didn't have the space for another 3380 in our computer room, and this was a perfect solution.
Call your IBM representative to test drive the new 9340. You'll get top-end performance without leaving your budget running on empty.
Since the devastating terrorist blast at the World Trade Center in New York, it is difficult now to enter an office, an airport, a train station without asking yourself, am I safe here? Like never before, security is on everyone's mind.
In an important security innovation at America's newest airport, U.S. Air, using IBM client-server technology, can pull checked bags if the passenger fails to board the flight.
Airports are busy places. At this modern-day crossroads where people and equipment intersect, information is critical, especially in hub airports like Pittsburgh International, where 65% of U.S. Air's traffic is connecting flights. Monitoring and tracking a high volume of passengers and baggage makes security a priority. U.S. Air has a computerized bar-coded system with the capability to match passengers by name with their baggage and track them on originating and connecting flights.
We have curbside check-in that allows our sky caps at the curb right outside of the ticket counter to be able to check in bags. Now that system of printers and touch screens is run by a series of processors, which are PS2s running OS 2.
This system can prevent a bag from getting on a plane without its owner. Completed in late 1992, Pittsburgh International Airport is America's most advanced airport. U.S. Air has integrated computer systems for reservations, flight displays, baggage, schedules, and ground crew information.
There's over 600 workstations that are interconnected on communication links to the host processors in Winston-Salem. There's no separate network. It all works off the same system.
Every workstation on that system can call up the same information, interface with other service areas to better monitor passengers, equipment, and baggage in and out of Pittsburgh International. Flight information for U.S. Air's entire route structure is also coordinated through the mainframe. So if a flight is delayed, other stations along the way are informed and updated at once.
It's important for us to get that information to the customer who might be waiting on that flight at the gate. The people on the ramp who have to service the aircraft, the baggage room that is handling the bags.
The synergy generated by the IBM host and PC system makes Pittsburgh International Airport a model facility.
The reason that we chose IBM to provide the basic architecture for this airport is that they were one of the very few vendors that, if anything, provided a total solution, hardware, software, and network. We believe at U.S. Air that we have positioned ourselves for the future and that there are many, many new application systems that we can install and deploy throughout the airport that will give us a very, very strong competitive advantage and take us into the year 2000 and beyond.
Not long ago, the steel industry was given up for dead by many, called a victim of modern technology. Plant expediters could not push products through the mill fast enough to keep up with foreign steelmakers. In our final report, we take you to Reading, Pennsylvania, where Big Iron wears a hard hat and has become Cartech's electronic expediter.
People think steelmaking is simple. It's very complex. We're a process industry. We're in a global competition. It is an economic war. We had to change our ideas about a lot of things. We call it continuous improvement. It's a complex system. We started with the realization that collecting data off the shop floor was a critical success issue for Carpenter. We elected to enter into a shop floor control design project with some idea that we wanted to take it into a flow system, what we refer to as a flow management system. The Japanese kind of started all this with their Kanban system, their JIT, but that was more of a physical space environment. And what we developed is an electronic Kanban system.
Our primary objectives were, number one, to reduce in-process inventory, improve the customer service, and thirdly, to get more accurate and timely data from the plant floor. We started first with the data collection system and worked very closely with the IBM folks down in Boca Raton to take a data collection, an industrially hardened data collection terminal to get the data to the mainframe. What happened then was to allow us to evolve into this whole process of pull-through manufacturing as opposed to pushing material through the mill. We now pull material through the mill based on downstream work centers' ability to take that material away.
It's important to have something pulling the material through so you can drive down the inventory behind each work center to a minimum. And we don't know how to do that unless you do that electronically.
We needed to have this whole data collection and shop floor system residing on the central brain, so to speak.
What we do, basically manufacturing with the new systems, new shop floor data collection and flow management systems, we've eliminated the paperwork. Prior to that, there was a lot of paperwork out on the floor, people manually updating things. Now everything is basically automated. We have ELF terminals on the floor where the people are reporting as they work on the operations.
Once completed with their operation, they will approach a data collection terminal out on the plant floor. They're basically swiping a barcoded ID badge which identifies themselves. Again, the two barcodes on the work order to identify the work order and again the operation that's being performed. This again becomes a unique part of our system. At that time, they will go up to the mainframe to pull down online information for real-time editing on the plant floor. I think this was probably one of the best examples of teamwork that I've been involved with in my 17 years in data processing, and it really was a triangular approach where you had IBM giving great support on the equipment development side. Computer Aid was the contract programmer that we chose to help us develop this system. And in addition to bringing the software expertise, they brought a lot of project management philosophy in here to Carpenter.
And we're collecting over 100,000 transactions a day. So it gives you some idea of the scope. 1,000 work centers, 100,000 transactions plus. That's 100 transactions to 1,000 transactions a day per operation, depending where you're at. It's awfully large, and that data is going into a database that's at this point 3.5 years old. So 100,000 transactions a day available for history purposes is an awful lot of information available for making improvement, and it becomes really becomes the heart of the analysis portion.
We've been looking now at 30 to 40% growth rates on an annual basis, rolling new CPUs in here at least annually. And you say, well, where's the increased load coming from? There aren't that many new transactions coming off the plant floor, and the answer to that is you're right. But now where the demand for the CPU is coming from is from our end users. In fact, the one vice president has a sign in his office that says, "In God we trust, all others bring data," so that all of their suggestions must now be database driven, and the need for the increased computing capacity and disk storage space is coming from those end users.
I can tell you that we currently have reduced our inventories in excess of maybe 15x of the original investment of the system. That's pretty good payback.
The other area which we'll be moving in fact, we have a pilot project started right now in our shipping department, will be to move into the client-server architecture. We feel that there's needs to move high-speed processing requirements down to the plant floor and allow the users to do online scheduling right at their particular work center. However, we still see the 390 being an integral part of that whole process as it becomes the repository and actually the big server for all of the clients that are going to be using it.
If we hadn't had the system over the last 10 years, I think we'd be hard-pressed to be doing nearly as well as we're doing right now.
I think you have to get out of the idea that it's a steel environment. It is supplying customers' need, and no matter whether it's service or whether it's retailing or apparel or steel or electronics or computers, it's all the same bailiwick. And I think the systems basically work in any environment. You may have to customize them unique to that business, but we feel strongly about that.
By the way, if you'd like to know more about the way Cartech uses IBM mainframe technology in a complicated manufacturing process, you can call Karl Marx at Cartech. Just call 215-208-2422.
2 weeks from today, we will be broadcasting another in our Technical Insights series. You'll learn how AT&T is reaching out with the client-server product WLFS, how 2 insurance companies are getting premium usage with LandRes, and how Philadelphia's PNC Bank is cashing in on EMIF, the electronic multiple imaging facility for ESCON.
And if you'd like a copy of this broadcast, or you want to tell us what you thought of it, please drop us a line. The address is IBM System 390 Magazine, Department 6TN, 44 South Broadway, White Plains, New York, 10601. Well, that's our System 390 Magazine for this time. The next edition's coming up in June. Thanks for joining us.
So long for now.